We're going to talk about how to write formulas, predict the products that will come out of mixing a couple of reactants and writing those formulas and then balancing the whole thing. Remember, there are 5 types of reaction. There's a combination or synthesis, which is where you just simply combine 2 things. There's sort of the opposite of that, a decomposition, where you have some sort of compound, ionic or covalent, and it is decomposed into its 2 constituents. You have a single replacement, which is where you have 2 reactants and one of them is ionic. And there is a single replacement. The X here comes over, it leaves B and combines with A. You have double replacement, where you have 2 ionic compounds, and basically you have a double switch here. A was bound to Y, it's now bound to X, and B has taken A's original partner, and then combustion, which is some carbon-hydrogen fuel plus oxygen makes CO2 and water. Those are our 5 types of reactions. Okay, so basically the way you do this is, here the first one is silver nitrate is mixed with potassium sulfate yielding whatever. Okay, well you start by writing the formulas. Silver nitrate. So, silver and nitrate, NO3, plus 1 and minus 1 is mixed with potassium sulfate, KSO4, plus 1 and minus 2. And it's, well, you have to recognize what type of reaction you have. We have 2 reactants, so it's certainly not decomposition. It's not combustion because there's no carbon, hydrogen, fuel, and oxygen, so we know it's not that one. So it could be a combination, but a combination is 2 elemental reactants like magnesium and oxygen. Number 1 here is 2 ionic compounds. Single replacement is 1 ionic compound, double is 2. So we're going to just switch these 2 negative things is the easiest thing to do. So silver was bound to nitrate. It's now going to be bound to the other negative thing, the sulfate, plus 1 and minus 2. Potassium was bound to the sulfate, but it's now bound to the other negative thing, the nitrate, plus 1 and minus 1. You have to write the formulas correctly. It doesn't matter that there were 2 Ks in potassium sulfate. There's only 1 K when it's bound to the nitrate because of the charges. And now you balance the whole thing. 1 silver, 2 silver. So if you ended with 2, you had to start with 2. That gives you 2 nitrates. 2 nitrates. 2 potassiums, 2 potassiums, 1 sulfate, 1 sulfate. It's all balanced. 2, 1, 1, 2. Move on to the next one, the combustion of butane. Well, it says it's a combustion. So we know that it's butane, C4H10. And because it's combustion, it's this carbon hydrogen fuel mixed with oxygen to produce CO2 and water. All combustions look the same. It's just these 2 little numbers here on the fuel that change. Now we balance. We'll start at the left and move on over. We'll start with the carbon. We have 4 carbons on the left, 2 on the right, or 1 on the right, so I'll make it 4 on the right. We have 10 hydrogens on the left, only 2 over here, so if I put a 5 here, that balances out my hydrogens. I have 2 oxygens on the left, and over here I have 8 plus 5 is 13. Okay, so I need to go from 2 from having 2 oxygens to 13. The least common multiplier is between 2 and 13 is 26. So I'll make it 26 on the left. And since I have 13 and I want it to be twice as much, I'll just go ahead and double these. That doubles my carbon, so I need to double my carbon. Okay, the combustion ones are kind of difficult, but not terribly so. I'll do one more, silver nitrate and sodium are mixed, yielding, well, this is 2 reactants, one of them is ionic. That means it's a single replacement. So we've got metal, silver, and the nitrate, and the metal sodium. So the sodium is going to come over here and replace the other metal, one positive thing replacing another. So we now have sodium bound to nitrate, +1 and -1, and the silver has been kicked out by itself. One silver, both sides, one nitrate, both sides, one sodium, both sides. It's all balanced. If you like, put ones out front if you need to. And that's it.